there's another beautiful thing that goes with this. Let's generalize this. Let's suppose that I have a production function with capital to the beta 1 and labor to the beta 2. Okay? And that's my production function. Remember that we already talked about school districts, for example, where we want to figure out what has an effect, right? Does adding, smaller the building size or the amount of building per student, the amount of capital we have per student, right? Or the amount of teachers we put against the student, class size, how does that affect? Could we add a variable in here for budget? Well, yes, we could. We could add all sorts of variables in here, make this more complicated, okay, and use it as a production function for education. The problem is, how are we going to regression this baby? And you're like, well, I don't know. I assume you're just going to tell me. And I am going to tell you. Because we're going to take the log of this. We're going to say log y equals log alpha k to the beta 1, L to the beta 2. And if we do that, we're going to get something that looks like this. Oh my goodness! It's a regression equation! It's a straight line, linear relationship regression equation from that nonlinear relationship between capital and labor and output. Okay? So if you say, I'm going to learn this log stuff, but I'm going to forget it. No! You're going to take econometrics. You're going to take more econometrics. You need to understand why you're often going to see these loggy things running around in your regression equation. They're there to create elasticities. They're there to turn nonlinear relationships into linear relationships. Okay? So hang on now, and we're going to do some regular stuff, but in the back of your mind, remember how important these loggy things are. All right. So how are we going to use these loggy things? How are we going to use them? We're going to use them for rates of growth, compound interest, but compounded continuously. Okay? So the value V equals AE to the RT. I can also discount things. I can say A equals V e to the minus RT, which is V divided by e to the RT. E to the RT. Okay? Just a little algebra on that, right? And I get that. So I can do present value. I can do future value. V is the future value. Right? A is the present value. And I can connect these guys with, continuously compounded. So if I have $100 at 10% for 2 years, continuously compounded, right? I'm going to have 100 times e to the 0.1 times 2 is 122.14. Okay? Or you could say, look, I have 100 million people in my country. We're growing at 10% a year. Or I have 100 billion GDP, which is growing at 10% a year. Where am I going to be in 2 years? Any of those options works, right? It doesn't have to be that I have $100 and I'm going to turn it into 122. It could be this is how fast my GDP is growing. It could be this is how fast my population is growing. Anything that grows continuously, okay? Anything that grows continuously, right? No? The old school way, the way you were taught before, you'd take 100 and you'd say 1 plus 0.1 to the 2 power, right? And you'd get 121. Well, 121, if you're continuously compounding, this is discrete. If you're doing it continuously, that's what you get. If you're doing discrete, that's what you get. Is that exciting? Let's try something else because we're very excited about these things. AE to the RT. What if I want my money to double? Well, V equals 2A is my money doubles, right? So I have 2A equals AE to the RT. Is everybody with me on that? Putting this, I want my money to double. So I have $100. I want to turn it into $200, right? So I want to ask a question like, if I have $100 and the interest rate's 5%, how long does it take my money to double? Well, I have this equation here that says 2A equals, right, AE to the RT. If I want to double and the interest rate is 5%, I want to find out what T is. Well, first, I can do a little math, right? I can get rid of that and get rid of that. So I can say 2 equals e to the RT. Then I could put 5% in for R. I can say 2 equals e to the 0.05t. Now, how do I solve this? I have 2 equals ERT. How do I solve this? I take the natural log of both sides. And what I get is the natural log of 2 equals RT What's the natural log of 2? Well, it's about 0.69. Have we ever been in a class where they said there's a magic number, which is 70 or 72, and you take the magic number and you divide it by 5%, and you get 14 years. That's how long it takes your money to double. Well, oh my goodness. That's the magic number. It's not 70 or 72. We rounded it off to get there. Okay? That's what we're really doing to get that t. Okay? So you may be saying to yourself, I don't need to know this, I don't need to know this, I don't need to know this. Well, guess what? You've been doing this in classes. With this magic number, you've been doing natural logs in e to the RT, and you didn't even realize it. Okay? No? Yes. Natural log of 2. All right. No? Okay. So we can solve this, we can use this to do all kinds of exciting little mathy problems, right? V equals A e to the RT. Someone offers you $1,000 in 5 years. What's it worth today? Well, that's $1,000 future value. Future, right? And A is present. So that's $1,000 equals A e to the whatever. And let's say the interest rate is 5%, and you got 5 years. 0.05 times 5. Now I just solved that for A, right? So the present value of that is $1,000 over E, right, to the 0.25. And that's the present value of $1,000 in 5 years at 5% interest. Continuously compounded, continuously discounted. Okay? You're saying, well, I don't need to do that. Yes, you do. So you're going to be an economist someday. Someday you're going to be sitting in your professor economist office or your consultant economist office. The phone will ring. You picketh it up. You go, economist. The person at the other end says, hello, I'm a lawyer. I have a dead person. And you're like, okay, tell me about this dead person. Well, this dead person was making $50,000 a year. They were 55 years old, and they were run over by a train. Wrongfully killed. Not rightfully killed, but wrongfully killed. Okay? How much should I sue for? And you say, not the answer to the problem. You say to them, $500 an hour. And they say, good, fine. And then you get your little spreadsheet out, and you be calculating this for $500 an hour. Okay.